Good afternoon, everyone. So for today's lesson, we are going to look at part 3 of the lesson, which we talk about project network. Okay, so previously we have already covered minimum spanning tree, maximum flow. So this week we'll talk about project network, and next week we'll talk about allocation problem. Then that's where we end the entire syllabus for max application. Okay, so today we're covering quite some number of topics, which is we will learn what is that meant by project network. So basically it means how to read a project network. So we have lesson E, today's 22nd of January. Okay, we will also learn how to identify the minimum completion time and also the critical path of a project network. And also what's the EST, what's the LST, the earliest and the latest starting time, and also how to find the flood time or the slack time. Okay, so these are all the things that we're going to cover today, and tomorrow we are going to continue with how to construct a project network. Okay, so yeah, without further ado, let's look at page 130. Okay, so let's go to the page. Okay, all right, so yeah, these are basically something that we have repeated just now. Okay, but then I'm going to adjust a bit for the learning outcome that you will be learning. Okay, so we will first start off to know how to use EST to actually identify what the critical path is and also how long is the minimum time that you need to complete a project. Okay, so we'll actually start from 4.3.7. So after that, then only we'll be looking at how to use forward and backward scanning to find out the EST and the LST. And last but not least, we'll talk about flood time. Okay, so basically these are something that we are learning today. Okay, so how to find critical path, how to find minimum time, how to determine the earliest starting time, how to determine the latest starting time, and also how to find flood time. Okay, so that's the summary for today's lesson. Okay, so a bit of prior knowledge before we move into the part where how to find the critical path first, which is to understand what a project network is, and also how to read a project network. Okay, so a project often involves many related activities, so some of which cannot start until one or more earlier tasks has been completed. So one way of scheduling such activity is to construct a network diagram. Okay, so for example, what we are having here is that this is a diagram for a project to wash a car. So which means that when you send a car to the, to a washing to a car washing workshop, okay, then that's how they will treat your car, right? So it's the same thing like when we talk about if let's say you want to organize something or you have a project to carry out in your work. So what is the plan that you are able to carry out the entire project? Okay, so it doesn't has to be like, in this case, we are talking about in terms of minutes, but project network can be used under the situation where you are talking about a day or you are talking about even in the units of months or in the units of weeks. Okay, so it much depends on the question itself. So you need to be mindful of what's the unit that is given. So in a project network, so for example, you can see that on the top of each of the edges, then this is where you are given the activity. So which means that this up meaning is a washing activity and it will take 9 minutes. Okay, so each of the activity will be presented by an arc. Okay, so an edge with a direction is called as an arc, right? I hope you still remember from topic 3.3 when we are talking about directed graph. Okay, so which means that this tells you that this is where the project will be starting. Then after that, you slowly move until the end. Okay, so the weights on the arcs show the task. Okay, which means the activity, for example, like just now we talk about washing, okay, so it's a task. Then after that, it will also show you the time that you need to complete the task. So which means you need 9 minutes to complete washing, you need 7 minutes to complete drying, and so on. Okay, and then the vertices that you can see here represent the checkpoint of the start and the end of a particular activity. So for example, this is the checkpoint telling us that this is the starting for washing, and then this is the ending for washing and also the starting for drying. Okay, so that's the idea for the checkpoint there. Okay, so that's why remember that checkpoint is not your activity. Checkpoint is like the starting and the ending of your certain task that you are looking at. Okay, so yeah, this is what I explained just now. So we are talking about a process of cleaning and also polishing a car. Okay, so you can see that in a project network itself, when we are trying to represent the entire project in a project network, right? That's where you can see direction, right? So that's why all the tasks must happen in sequence in the direction of the arc. So which means that you cannot go washing, then after that you go polishing, then you come back to cleaning inside, then you go back to drying. Okay, so it must continue with sequence. So which means that all the activities cannot start until the preceding activity is completed. Okay, until the preceding activity is completed. Okay, so preceding activity meaning like the activity that you must complete before you move on to the next. So which means, for example, you can see that we must make sure that we wash first before we dry, right? So it cannot be you go dry first, you dry first, then after that you go and wash, right? So which means that you can say that the wash is the preceding activity for drying. Okay, so we must also make sure that, for example, we need to make sure we wax the car first before we polish the car. Okay, we need to wax first before we polish the car. And also the same thing, we must make sure that we clean inside first. We clean inside first, then only we go and deodorize the car. Okay, so clean inside before deodorize. Okay, so this is what we talk about in sequence. Okay, so besides, you can see that sometimes for the checkpoint, then you can have like more than one edge that actually continue from a certain checkpoint. So which means that these are some activities that you can perform simultaneously. So beside there are activities that you can perform simultaneously as well. So for example, after you dry the car, you can actually do waxing and also clean inside at the same time. Okay, I mean, given the situation where you got enough manpower, then you are able to do that, right? So for example, we can wax and also clean inside, okay, at the same time after dry. All right, okay, so that's the idea for how do you read a project network. I hope it's actually quite direct, right, for this part. Okay, so basically for you to understand what is this thing means. Okay, so now we are going to move on to our first learning outcome, which is to learn how to find out, how to identify the critical path. Okay, so first of all, we need to understand what a critical path is first. Okay, so critical path analysis is basically a method for you to determine the critical path. So what is that meant by critical path? Critical path is the longest path in a network. So later after we got the critical path, then you understand what is that meant by longest path. Okay, so this critical path will determine what is the minimum completion time that you need to complete a certain project. So it determines the minimum completion time. Okay, so that's why I would say that actually critical path analysis is the most important thing for this subtopic. Okay, because I mean sometimes the question wouldn't ask for EST and LST for all, but then you will definitely get a question where to ask you you know, what's the critical path and also what's the minimum completion time for this project. Okay, so at sometimes you can get more than one critical path, so it will be much based on, you know, depends on the question that you have. Okay, so now let's try to understand what is that meant by critical path and how do we do that. Okay, it's actually not very difficult, but you must just make sure that you don't you know, like when you're given a picture, then you know that this is a project network, then you remember what's the algorithm to do. Okay, all right, so and also I would say that try to understand the thing that you are doing. I mean, after you do it for a few times, after you are familiarized with it already, it can change to a set of like skill or a set of steps that you are following. Okay, but then it's good for you to understand why you are doing so, so that in exams itself, you know, sometimes you might forget and confuse about something, then you are able to think about it from a logical perspective. Okay, great. So first thing, when we start off with a project network, that's where we spend 0 of our time, right? So that's why for the first node, we are going to put in 0. Okay, so which means that this is where the project starts. So of course, if let's say your arrow is from the right to the left, then on the right is where you put 0 lah. Okay, so we spend 9 minutes for washing. So which means that the earliest time that we are able to start drying is going to be 9 minutes into the project, right? So which means that this is the vertex that telling us the end of washing and the starting for drying. So which means at the 9 minute, you should have completed washing and then you continue with drying. Okay, remember we are talking about minimum completion time. So definitely if let's say there's any delay, you can spend like, let's say 10 minutes, 11 minutes, okay? But what we are trying to do is, you know that this task need 9 minutes, then if let's say everything follow the time that you need, then this is 9 minutes is what you need lah. Okay, so 9 minutes is where you will be ending your washing and then starting your drying. Okay, so the 9 is actually depends on washing, right? So we put a tick on washing because later we need to write down all the activities that decide the minimum completion time. Okay, so in the 9 minute, we start drying and then we take 7 minutes for drying the car. So that's why by the time that we end drying, it will be 16 minutes into the project already. And this 16 minutes is based on the drying here as well, right? So that's why we put a tick at drying as well. Okay, then we continue from there. So after 16 minutes, we can start waxing and also cleaning inside at the same time. So we need 8 minutes to complete waxing. So which means by the time that we finish waxing or starting polishing, it's supposed to be 24 minutes and it will be based on waxing. Okay, it's because of 16 plus 8, you get 24 more, right? So you take 10 minutes for cleaning inside, so that time when you finish cleaning inside is supposed to be 26 minutes into the project, and this 26 is actually coming from cleaning inside. Okay, then we move on from here. Okay, this is where you will get a bit confused because we are talking about a very direct diagram. So later when we are doing a more complicated, a more complicated situation, then you'll be very careful with all of this. Okay, so we need 6 minutes to complete polishing. And by the time we start polishing, it's already 24 minutes, right? So that's why by the time we finish polishing, it's supposed to be 30 minutes. Okay, but then we only need 1 minute for deodorize and we can start at 26 minutes. So by the time we finish deodorize will be 27. Okay, so now if let's say for this is 30 minutes, then this is 27 minutes, then what is the number that I should put in this note? Okay, so the question to ask yourself is that, is your project considered completed if let's say you finish deodorize but polishing is not finished yet? Not right. So you must make sure that all your tasks are completed, then only you can consider that's a wrap for your project, right? So that's why although deodorizing finish faster, but then you need to wait for the polishing to finish, only the entire project is considered completed. So that's why the minimum completion time for this project will be 30 minutes. All right. Okay, so that's the idea of it. And also, how do we get these 30 minutes is actually from polishing, right? So that's why we put a tick there. Okay, so first thing, what is the total completion time? Is going to be the number that you put in the last vertex. Okay, so that's why we have 30 minutes here. So minimum time that we need to complete the entire project will be 30 minutes. Okay, so the next thing we talk about the critical path. You remember where we put all the tick is? Okay, so you try to look at your last note, then you try to find out the tick that you put, then you start to trace back. So which means that you have polish, then before polish you have waxing, before waxing you have drying, before drying you have washing. So that's why the critical path for this project network is wash, dry, wax, and also polish. Okay, so this is what is that meant by critical path. Okay, so in the next part, we will talk about, what is that so important about critical path. Okay, so you can see that the way that we are putting our tick, right, is because of the time that we are writing in a checkpoint itself. It depends on this activity, am I right? So that's why all this activity on the critical path, we call it as critical activity. Critical activities. Okay, so why do we need to know what activities are on your critical path or which activities are the critical activities? Because of all the tasks which is on the critical path, they cannot afford any delay. Okay, I repeat one more time. So critical activities is as the most important activity. So you must make sure that all these activities are not delayed, because if let's say you delay any task on the critical path, right, then your minimum completion time will be delayed as well. Okay, so that's why something that you will realize is that you see, right, this is our critical path, right? So when you are adding 9, 7, 8, 6, that's where you get 30. So which means that no matter which one that you get delayed for let's say 1 minute, then you know that your minimum completion time will become 31, right? So that's why these are the path that decide your minimum completion time. So that's why they are called critical path, because they can't afford any delay. If you delay, then your completion time for the entire project will be delayed as well. Okay, so it's the same idea here. The activities that are not on the critical path, they are called as non-critical activities. Non-critical activities. All right, so if let's say for those activities that's not on the critical path, or we call them as a non-critical activities. So these are the activities that could be delayed within a certain time, and yet we are able to complete the entire project within the minimum completion time. Okay, for example, just now we say that wash, dry, wax, and polish is the critical path, right? So which means that clean inside and deodorize is not the critical path. Okay, so let's write down. Okay, remember this tick, okay, it means that for this time, 26 is still based on cleaning inside, but it doesn't mean that all the activities that you put tick is a critical path. Because critical path, we are talking about the entire series of the task from the beginning, and the ending is giving you the maximum time. So that's why there could be like a lot of things that you are putting tick, but putting the tick doesn't make it a critical activity. So remember that, okay? So you are looking at the entire path that you are having a tick, then only they are critical activities. Okay, so which means in this case, we have the activity for clean inside and also deodorize. They are non-critical. Okay, so now we try to understand why are these activities non-critical? Okay, so we will be looking at the last one first. Okay, so you can see, right, although you finish deodorize at the 27 minutes, however, you need to wait for another 3 minutes, then only you consider the entire project is completed. Am I right? So which means that if let's say I don't have enough manpower, so I can actually drag this activity for 3 minutes. Because imagine if let's say I spend 4 minutes in deodorize, I will still be able to finish this project within 30 minutes, right? Because 26 plus 4, I still get 30, which my completion time for this project network is still 30. It wouldn't create any delay for my completion time, right? So that's why the deodorize could be delayed for 3 minutes from what we have explained just now, and we are still able to complete the project within the minimum completion time. And basically this time is what we call as slack or float time. So later when we learn about EST and LST, we will try to dive into this a bit deeper. Okay, but for now, this is what you try to understand first. Okay, try to understand the idea why they are non-critical activity and what is that meant by you can delay within a certain time. Okay, because for example, you can imagine that if let's say now my deodorize take 10 minutes, then you wouldn't be able to complete the project within your minimum completion time already, right? So if let's say it take 10 minutes, then you will get 36. Okay, so that's why we will always say that these are the activity that could be delayed within a certain time. It's not that how long you want to delay, you can do that. Okay, so similarly, imagine this. If let's say deodorize, we still need only 1 minute. Okay, then which means that what happened here is that we have the 3 minutes of the free slot for clean inside as well. Because imagine you need to write this, or you want to write also can, but I'm just writing it for the sake of my explanation. Okay, so that's why it's fine that you don't write this part. Okay, so imagine what happened just now. We got extra 3 minutes, right? So imagine now the extra 3 minutes happened in cleaning inside. Okay, so you can see that 16 plus 13, by the time I finish cleaning inside, is only 29. So if I only need 1 minute to deodorize, I will be able to finish my project within 30 minutes as well. Okay, so that's why I said that it's not that the activities that you are putting tick, they are all critical activities, because if let's say the next one is non-critical, right, then which means that you got extra time for the previous one as well, because you are not rushing to finish this in order for you to in order for you to proceed with your next activity. Okay, so that's why for clean inside, you are able to delay this activity by 3 minutes as well. And also you are still able to complete the project within the minimum completion time. So that's why the slack or the float time for clean inside is also 3 minutes. Okay, so that's the idea for what is that meant by critical path. How to find out the total completion time, and also what is that meant by critical activities and also non-critical activities. Okay, so now we'll be looking at one example. So perhaps we will do the first one together, then the second one, I will want you to pause the video, then after that try it out first before we proceed. Okay, so example 1, find the minimum completion time and the critical path for the project network shown below. Okay, so the arcs represent the task involved, and also the number of the arcs indicate the time in days the task required. Okay, so remember it's similar to your maximum flow and also your minimum spanning tree. So always be mindful with what is the unit that is given. Okay, so whenever you are given your minimum completion time, you should give with the right unit. Okay, because when you say 5 days versus 5 minutes, they are very different thing, right? Okay, so that's why remember to put in the unit. Okay, so remember when we start off, that's where we put 0. It's the same thing like in the maximum flow, that's where you have your source and also your sink, right? So that's why in your project network, remember that this is where your starting checkpoint, then you remember to check your direction and to understand where is your starting checkpoint and where's your ending checkpoint. Okay, so that is important, but remember that the word source and sink is only for maximum flow, is not for project network, yeah? Okay, so the same thing, we take 5 days in order for us to complete task A. So that's why by the time that we can start B and C, it's going to be 5 days into the project. Okay, so how do you get the 5? It depends on project A, right? It depends on task A, sorry. Okay, then after that, same thing, we need 6 days to complete D, but you can see that for this checkpoint, it's going to it's going to decide what is the starting time for you to start G. So that's why it's important for you to remember, like, you need 5 days to complete A. So that's why plus another 4 days to complete C. But by the time that you reach this checkpoint, it's already 9 days. And then you need only 6 days to finish D. So that's why even though D is completed earlier, but then you still need to wait for C to complete first before you can actually start your G. Okay, so that's why we are going to write 9 here, because this is the time that you are able to start your G. Okay, I hope that's clear. So let me repeat one more time. So you need 4 days to complete task C. So by the time that you start task C, it's already 5 days into the project. So 5 days plus 4 days are till the time where you finish task C, it's already 9 days. Okay, since you only need 6 days to complete D, then which means that while D finish first, then you need to wait for C to finish, then only at the same time you can start G. So that's why if you are writing 6 here, actually it's not correct, because this is the checkpoint for the ending for C and D. So, but then during the 6 days, you actually didn't complete C yet, and you need to wait for both activities to complete first before you can move on for G. Okay, so that's why we put in 9 here. And how do you get the 9? It depends on C. So that's why remember to put a tick at C. Okay, then after that, same thing, we need 7 days to complete E. So that's why 7 days to start off with activity F. Okay, then we continue with this first. So 5 days here, and then, oops, sorry, I tick. Okay, so 5 days when we start activity B. So activity B take 4 days to complete. So that's why by the time we end activity B, or by the time that we can start H and I, is already 9 days into the activity. Okay, so looking at this checkpoint, so you need to be very careful because you can see there are 2, 3 arrows that directing to this checkpoint, right? Okay, so 9, 4, that's where you get 13 by the time you complete H. So 9 plus 1, the 10 days when you finish G. So 7 plus 2, you got 9. Okay, so that's why F and G will finish earlier before H, but then you still need to wait for H, then only you are able to start J. Okay, so that's why we have 13. And how do we get 13? It's actually based on H. So I'll put at H. Okay, then after that, for the ending here, you can see that this is 2 arrow. So 9 plus 6, you have 15 by the time that you complete I. So 13 plus 3, then by the time you complete J, it will be 16 days into the project. So that's why even though we finish I first, but then since J is not completed, we still need to wait for J to complete. So that's why the minimum completion time for this project network will be 16 days. Okay, and then how do we get 16 is actually based on J. So now you start to backtrace. So you can see J. So before J, the tick is at H. Before H, the tick is at B. Before B, the tick is at A. So that's why your critical path will be A, B, H, J. Okay, so that's how we write down the critical path. So for minimum completion time, then it will be the time that we are writing in the last checkpoint. So we have 16 days. All right. Okay, so now for question 2, what I want you to do is try to pause the video and try to do it yourself first. So spend like 2-3 minutes to complete this question before you continue to check your answer. All right. All right, I hope you have tried, and let's discuss the answer. Okay, so for this question, yeah, same thing. You find out the minimum completion time and also the critical path, and the time is in hours for this question. Okay, so same thing you can see that all the arc is directing from the left-hand side to right-hand side. So this is where your starting checkpoint. Okay, so we need 6 hours to complete P. So that's why by the time that we can start this 4 activity, is going to be 6 hours into the project. So that's why a tick at P. So Q, you only need to make sure that Q is completed when you start this. So that's why we have 14. Okay, so for this one, you need to be careful. So you see that there are 3 arrows that directing to the same checkpoint, right? So 14 plus 3, by the time you complete U will be 17 hours. By the time you complete R, it will be 14 hours. By the time you complete S, it will be 18 hours. Okay, so that's why U and R is going to be completed first, but then we still need to wait for S, then only we can start X. So that's why we have 18 here. And how do we get this 18? It's actually from S. Okay, so a tick at S. Okay, then after that, continue with this part. So you can see that you need all W, X, and also T in order for you to start Y. So that's why 14 plus 9, we have 23. Okay, then for X will finish in 22 hours. For 9, it will be 9 plus 6, which gives us 15. Okay, so that's why by the time that we finish all the activities that is needed, is already 23 hours into the project, then that's where we can start Y, right? So how do we get 23? It's actually from W9. Okay, then continue from there, 14 plus 18. So once you complete U, you can start V already, and it will take 18 hours. So which means in total, we have 32 hours when we complete V. So for Y, it will be 29, 23 plus 6. Okay, so that's why while Y finish first, we also still need to wait for V. So that's why we take the larger number. So we have 32. And how do we get 32? Is from V18. Okay, so that's why backtrace the tick. So the ending. So you can see that the first one is going to be V. So after V, the one in front is Q. After Q, then is P. Okay, so that's why the critical path here is PQV, and the minimum completion time is 32 hours. Okay, so that's this question. I hope that you get it correct. If let's say you cannot get this part correct, then you must make sure that you go through again the video to make sure that you understand the thing. Because later when we are moving towards EST, LST, it will be even more complicated. Okay, so that's the part for example 2. Okay, let's finish the notes. So critical path analysis is about the project at a macro level, which means that we are talking about the entire project. So it will tell us the project as a whole. And later when we learn forward scanning and backward scanning, we'll be looking at individual tasks, okay, in a much more in a much more specific idea where, what happened to X, then what happened to R, what is it special when I have tick or don't have tick, those kind of thing. Okay, so make sure that you are able to get this part first before you proceed to the next part. All right, for this part, we are going to look at individual tasks now, which we will be looking at the second learning outcome, which we talk about forward scanning and also backward scanning, and what is that meant by EST and LST. Okay, all right, so first thing, we'll start off ESTs first, because EST is actually quite easy. It's basically whatever that you have done just now. Okay, so forward scanning enables us to determine the earliest starting time. Okay, which in short, we will call it as EST. So earliest starting time. Okay, so the earliest starting time for each activity in a network. So this is the earliest time that it is possible for us to start the specific activity. Okay, so how to do earliest starting time? Okay, it's actually exactly same thing that you have done just now, but then the way that we are trying to understand it going to be a bit different. But when you try to think about it, it's actually something that is logical and something that makes sense. Okay, so for all the notes now, we will try to separate it into two parts. So which means that you are going to write two numbers in each of the checkpoint. Okay, so be mindful that your handwriting, okay, the size you need to make it a bit smaller so that you are able to write down two numbers in one note. Okay, so this is where we start just now, right? So 9. Okay, so the way that we understand just now is we need 9 minutes to complete washing. But then when we are writing 9 here, so this is the time when washing ending, but this is also the time for drying to start. And 9 minutes is also called as the earliest starting time because you need 9 minutes for washing, right? So which means that if let's say there's no any delay, 9 minutes into the project is the earliest time that you are able to start drying the car. So this is why it called as EST, which is earliest starting time. So you need 7 minutes to complete drying. By the time you complete drying, it's already 16 minutes. So this 16 minutes into the project is also the earliest starting time for waxing and clean inside. So why is it earliest time? Because when you are following the standard time, then this is the time that you can start. So if let's say there's any delay, then it's going to be later than 16 watts. So, but then since you need 9 minutes for washing, 7 minutes for drying, so 16 minutes into the project is the earliest time that you are able to start waxing and clean inside. Okay, so same thing, continue. You need 8 minutes for waxing. So which means that by 24, when you finish waxing, that's the earliest time that you can start polishing. Okay, so 16 plus 10, 26 is the earliest time that you can end cleaning inside. Is also the earliest starting time that you can start deodorize. Okay, then after that continue. So 24 and 6 versus 26 and 1. So it's the same thing just now. So we are writing 30, right? Because this is the earliest starting time that we can end the entire thing. All right, so that's what you have. Okay, so remember that when you're looking at the checkpoint, right? Okay, normally the question asks for earliest starting, but you also need to understand that, for example, this is drying, right? So which means that 9 is the earliest time that you can start drying. 16 is the earliest time that you can end drying. It's also the earliest time that you can start waxing. I hope that makes sense. So for polishing, so 24 is the earliest time that you can start polishing, and then 30 is the earliest time that you can end polishing. Okay, but then you need to remember that for your EST and LST, we are talking about individual tasks. So for things that is in one note and it's actually because of 2H, you need to remember that 30 is not the earliest time that you can end your the rise. 27 is the earliest time that you can end your the rise. Okay, so when later when we are talking about LST, this idea will be, I mean, more important. So that's why do make sure that you understand how you are looking at it and also what is that meant by EST. Okay, so if let's say not to make you confused, you only remember that whatever you are doing is EST first for now. Okay, so which means that like that's the earliest time that you are able to start a particular activity. Okay, so which is basically what you have done just now, which you realize that 9 is actually, depends on the, so if were to understand in this way, right, EST, okay, why we are calling it as forward scanning, because you are looking at the starting until the ending, so you are moving forward. Okay, so that's why this approach is called as forward scanning, and the number that you are writing is called as earliest starting time. So you can also say that forward scanning or earliest starting time is the way that for you to identify your critical path as well, because you are doing exactly same thing, but it's just that the way that you're understanding it now become EST already. Okay, so when you are doing this, then you can see that, for example, the earliest starting time, so this is the starting checkpoint for waxing. So the earliest starting time for waxing is 16 minutes into the project, because it is the soonest time that you can start waxing, because you must make sure this two is completed first. So by the time that you can start this, it's going to be 16 minutes. Okay, so that's earliest starting time. I hope everyone is fine, and I think you should be fine, because it's exactly the same thing like how you did it just now. Okay, but then we are going to look at the second one now, which is going to be a bit more confusing. So do make sure that you take time to digest and understand it. Okay, so second one, we talk about backward scanning. So for backward scanning, it helps us to determine the latest starting time. Okay, backward scanning helps us to determine the latest starting time, which is called as LST. Okay, so for this, we are going to do everything in the diagram first, then after that we look at the notes. Okay, so you can see that, no worries, because all the explanation I have put in words here. So, next time when you are reading it again, then you should be able to understand it. Okay, so for example, this activity should be completed within 30 minutes, right? So this is where your 30 is. So that's why when you are looking at your final or your ending vertex, that's where you write down the LST as well. Okay, because it doesn't make sense when we are talking about how late you can drag the activity, right? Then which means that it can be infinity. I can write 50, I can write 60. Okay, but we are talking about the idea where how much you can drag each activity for you to still complete the project within the minimum completion time that you have, which is 30 minutes. So that's why the LST and the EST for your last node must be the same, which, how do you get the node, which is just following the EST? So the LST for the final vertex is going to be the same with the EST then. Okay. So when we are looking at this, then let's try to understand it from the idea for deodorize first, maybe. Okay, so you can see that since deodorize, you only need 1 minute, am I right? So that's why, which means that you can actually start this activity as late as 29 minutes, and you still be able to finish the activity within 30 minutes, right? If you start at 29 minutes, you only need 1 minute for deodorize, then you know that you will definitely finish on time. So it's the same thing like, for example, I know that for this homework, I only need 1 hour to finish it. If let's say today I got 2 hours to do it, then I can drag for another 1 hour because I only need 1 hour to complete it. Okay, so that's the idea. So which means if I push it the latest time that I start, I can start at 29 and still be able to finish this. Okay, so let's look at the notes here. So which means that since deodorize need only 1 minute to be completed, we can start the task as late as 29 minutes into the project. And to remember that when we are writing the LST, it means that this is the latest time that I can drag, and it will not affect the completion time. So 29 minutes is what we call as the latest starting time, which is the LST. Okay, so by definition, the LST is basically the latest time for you to start a specific activity without affecting the minimum completion time. Okay, so if let's say you are able to understand this, then let's try to look at polish. Okay, if you need to complete this project in 30 minutes, and if you need 6 minutes for polishing, then you know that the latest time that you should start polish is still 24, which is the same with your EST. Why? Because if let's say you start a bit later than 24, then you wouldn't be able to complete this project within 30 minutes already, right? So why is that so? Because if you try to recall the thing, right? Wash, dry, wax, and polish are critical activities. So these are the activities that you can't delay. So under the situation where you can't delay, which means your ASC and LSC is supposed to be the same, because the latest time is also your starting time because you can't afford any delay. So for deodorize, you can see that the LST is going to be later than EST because you have these 3 minutes flexible for you to delay. And because of deodorize is non-critical, so that's why you will still be able to finish the project on time. Okay, so try to understand this. So for polishing, the latest starting time is 24 minutes into the project. Okay, so that's what we have here. Okay, maybe let's try to write down this one first. Yeah, okay, so on the critical path, you can always see that the EST and LST is always the same at each vertex. So as what we have explained just now, okay, because what do we have just now? Yeah, because polish is a critical activity, so that's why you see that the EST and LST is the same. Okay, so now we move on for this part. Okay, so to look at waxing and also clean inside. Okay, so now what happened is that we try to assume that we push deodorize as late as it is. So which means that we are going to start because, okay, remember this when you are doing forward scanning, then you finish forward scanning. So finish your forward scanning, then only you do your backward scanning for your LST. So from backward, then you must look at the ending until the starting. So whatever that you are writing for your EST, right, it doesn't related to your LST anymore. So which means that if let's say I'm looking at latest now, right, which means I will assume that if I start deodorize with the latest time, then what is the latest time that I can start cleaning inside? So that's the idea. So which means that I won't be looking at EST anymore. So when I do LST, then I only look at all the number at the bottom. So that's the idea. Okay. So imagine now, deodorize will start as late as 29 minutes and you need 10 minutes to complete cleaning inside. So it means that I can actually start cleaning inside as late as 19 minutes into the project. Am I right? Because 19 plus 10, then I will still able to start deodorize at 29 and I only need 1 minute to start deodorize and I can still finish everything within 30 minutes. Okay, so the issue is that why do I need to write 19 here instead of writing inside? So it's the same thing. Just now, right, when you are doing your forward scanning, you are looking at these two edges directing to this vertex. So that's why you need to check both of these to decide what to write in this note. So it's the same thing over here as well. We know that for clean inside, the LST is actually 19 minutes into the project. But then because you are doing backward scanning, then there are two edges. When you go backward, it will go to this node. So that's why you must make sure that you are looking at these two nodes before you decide what number to write here. So if you can start polishing as late as 24 and you need 8 minutes to wax it, then you know that you will need to start your waxing as late as as late in the 60 minutes. Okay, because you need 8 minutes to complete. If let's say the latest time that you can start polishing is 24, then you must make sure that the latest time that you can end waxing is also 24. So only if you start at 16, then only plus 8 minutes, then you are able to finish this at 24, then only you can start polishing. Am I right? Okay, so now which means that for clean inside, the LST is 19 and for waxing is 60 minutes. Okay, so now what do we need to do is to consider both circumstances. So now thinking about this, imagine the logic behind this. If let's say I am writing 19 here, okay, so try to think about, can I put 19 here? If I put 19 here, I need 10 minutes finish cleaning inside, then I'll get 29, right? So 29 plus 1, okay, no issue. I can still finish the project in 30 minutes. But you realize that if let's say you say that you can start these two, because this node is meant for these two, so if let's say you start the activity, you can start the activity as late as 19, right? By the time you finish waxing, it's already 27. And if let's say 27, you need another 6 minutes to finish polishing, then it's already 33, which you are not achieving your minimum completion time anymore. Am I right? So that's why the idea is that if let's say you are putting the later time, you won't be able to finish the earlier one that you need within the completion time already. So that's why when you are doing your backward scanning, you are going to go for the smaller number. Okay, because if let's say you say that the latest starting time is this, then you know that waxing and polishing can end on time. And for this one, 16 plus 10 plus 1 is still lesser than 31. Okay, but then you need to remember that this is a 16 only for this checkpoint because you need to consider both. But if the question asks you what is the LST for clean inside, your answer is 19, not 16. So you must be very careful of that. Okay, because when we are talking about ESC and LST, we are talking about individual tasks. But when we are writing in the note, we are considering all the age that backward and going back to this node. Okay, so that's why in the note, the LST will be written as 16 minutes so that the minimum completion time would not be affected. Because if let's say we try to write 19, then it will no longer be possible for us to complete the whole project in 30 minutes. Okay, so this is what we do just now. So we can always carry out forward scanning to check whether or not it makes sense. So for example, like what I said just now, if let's say you start this as late as 19, then when you check 19 plus 8 plus 6, then you wouldn't be able to reach 30 anymore. Okay, so let's finish the last two. So the latest time that we need to start waxing and cleaning inside is 16, which means this is the latest time that I need to end drying. So that's why I need to start as late. Okay, the latest that I can dry is 9 because 9 plus 7 only I can get 16. Okay, so 9, then 9 minutes. So that's why I go back to this is 0. Okay, so something that you must be very careful is that when you are writing when you finish the entire thing at the node here, right? Your first node supposed to be always 0, 0. If let's say the latest starting time for this one, you are not getting 0, then that's definitely going to be a mistake that you have done. Okay, because you will definitely has critical path. So that's why the critical path needs to start at your starting point as well, right? So that's why you will definitely get your first node 0, 0. If you can't get it, then which means something is wrong. Okay. So when we are looking at this, some tips that you can try to write down is that when you are doing your EST, okay, which means when you are doing your forward scanning, right, just now, which is how you write the top number, how do you decide? Okay, for example, when you're having two choices, you are going to pick the larger one. So when you are doing your EST for your forward scanning, right, you pick the bigger number, which means like just now, among 30 and also 27, we pick 30. Okay, because the idea is that I need to wait for the other to finish first, then only is considered complete. Okay, so pick the bigger one. Okay, but when you are doing the LST, so for example, just now, so this is the node that you are having two age that going backward to that. So there are two numbers to check as well. And when you are doing that, you are picking the smaller number. Because if you pick the bigger number, then you wouldn't be able to complete the entire project within your minimum completion time anymore. Okay, so there's some tips that you can do. But as what I say, try to understand it. Okay, try to understand it rather than memorizing it. Okay, and something that you can check during your exams or when you're doing exercise is that because LST, we are talking about later starting time. So when you are looking at each of the node, right, it will never ever that your LST is smaller than your EST because your latest starting time is definitely later. So that's why the number is either equal or more than that. Okay, your LST cannot be a number that's lesser than EST because it doesn't make sense. Okay, so that's the idea for this one. Okay, so for now, or instead of straight away moving to the float time and slack time, right, we'll be doing the example first so that you are able to understand the EST, LST before we move on. So similarly for this question, we will do one example together. Then after that, you will need to pause your video. Then you will try your second example before we move on for discussion. Okay, so this is exactly the same diagram as we have previously, but then we are going to now practice the find out the EST and LST for each of the activity here. Okay, all right, so we have same thing, the starting, that's where we put 0. Okay, so we need 5, I think this is 5 days. Yeah, correct, sorry for that. Okay, so we need 5 days to complete A, so which means the earliest time that we are able to start B and C is the 5th day. Okay, so continue. We need 4 days to, okay, sorry, I just want to clarify one thing. Okay, sometimes in the exams itself, they will just ask you to find out the critical path. Then in that sense, you only need to write down like one number. Okay, but then if let's say the question asks about ESC and ISC, so that's why sometimes you will just write up and down, so it's easier for you if let's say there's following question they're asking for EST, LST. So that's why you don't separate the two method that you are doing, which means when you are doing EST, it's also the way that you are doing your critical path as well. Okay, because the way that you are doing EST is exactly the same way like how you find out your critical path just now. Okay, so that's why you put a tick as well when you are doing that. Okay, so same thing, we need 4 days to complete B. So the earliest time that we can start H and I is 9 days into the project. So we need both C and D to be completed, then only we can start G, right? So the earliest time that we can finish C is 9 days. Earliest time that we can finish D is 6 days. Okay, so that's why the earliest time that we can start G will be 9, because I need to wait for both to finish, then only I can start G. So that's why I take 9. Okay, remember going forward, take the larger number. So that's why 9 and 6, I pick 9. Okay, so continue. E needs 7 days. So that's why that's the only thing that directing to this node. So no need to check. So 7. Okay, continue for this node. You must make sure H, G, and F all finish before you can start J. So that's why by the time when H finish is 13, then 10, and then you have 9. So that's why you must make sure that all 3 is completed, only you are able to start J. So the earliest starting time for you to start J will be 13 days. So that's why it's from H. Okay, so 9 plus 6, you got 15. 13 plus 3, you have 16. Okay, so that's why by the time when I finish, J is not finished yet. So we need to wait for J finish, then only consider the entire thing finished. So that's why J, and that's we take 16. Okay, so that's why it's the same answer where you get A, B, H, J as your critical path. Okay, so that is the thing that you should have already known. So now we try LST. Okay, so for the last node, your LST is the same with the EST. So we have 16 and 16. Okay, so 16 is the latest time that you should end everything if let's say you want to have the minimum completion time of 16 days. Okay, so we go backward now. So now you can see that for this node, this is the only way that you go backward and you reach this checkpoint. So that's why 16 minus 3, which means if you, let's say you want to end J at 16, the earliest time that you should start J is 13 as well. So there's no issue because that's 1, which is quite straightforward. Okay, then after that, you will realize that for this node, okay, when you move backward, then there are 2 H that go backward and you go to this checkpoint. So which means that you need to check both. Okay, if let's say you want to achieve 16, then it will be 16 minus 6. That's where you get 10. Okay, which means if you want to finish this at 60 minutes, the latest time that you need to start I is 10. Because if let's say you start later than 10, then you wouldn't be able to reach 16 already. Like if let's say you start 12, then your minimum completion time will become 18, right? So 16 minus 6, we get 10. So 10 is the latest starting time for I. Okay, so 13 minus 4, you get 9. Okay, so which means that if let's say the latest time that you must start J is 13, then I must make sure that H end at 13. If I make sure H to be end at 13, then I must make sure that it will start at 9. Okay, so that's why you need to look at these two numbers. Going backward, choose the smaller number. So that's why 9. Because imagine if you are writing 10 here, then 10 plus 4, you wouldn't be able to start your J at 13 anymore. Okay, I hope that makes sense. So try to understand it. So going backward for this node, there's only one edge that going backward. So 13 minus 1, which means if you start G as late as 12 days, you are still able to finish the thing at 13 so that you are still able to achieve the minimum completion time of 16. Okay, so 13 minus 1, you get 12. So this one is also quite straightforward because you have only one number. So 13, okay, 13 minus 2, then that's where you get 11. Okay, so which means that if you start F as late as 11 and then you need another 2 days, you are still able to finish everything at 13. So that's the idea of it. So when you are looking at this node, then you need to check both, okay, because you have two edges that going back to this. Okay, so we have 9 minus 4, you get 5. 12, okay, remember you only look at the LSD when you are doing LSD. So 12 minus 4, you get 8. So that's why you can actually delay C a bit, but because of B must start at 5, so that's why this node you must write 5. So going backward, choose the smallest number. Okay, so for this one, then you need to check. It's good to check, although you already know that it's going to be 0. Okay, 5 minus 5, you get 0. 12 minus 6, you get 6. 11 minus 7, you get 4. So that's why you are definitely having one path that give you 0, and that's going to be your critical path. So that's why you can see A, B, I. A, B, H, J. And that's why you realize along A, B, H, J, right, you got all the EST the same with the LST. Okay, so that's how you find it. But just remember that if the question asks for LST for a specific activity, for example, what is the LST for E? Your answer is 4, not 0. What is the LST for C? Your answer is 8, not 5. Okay, because you are writing 5 because of these two, but then actually the LST for C is 8. Okay, so that's the idea of it. Okay, so now is your turn. So pause the video again, try out second question. All right, I hope you have tried. So let's discuss. Okay, so this is a project network in hours. Okay, so EST is exactly same thing that we have done. So I'll go through it a bit faster. Okay, so we have 0 here. So if let's say we need 6 hours to complete P, then which means by the time that we can start QRST, the earliest time that we can start this 4 activity is going to be 6 hours into the project. So continue with 8 hours to complete Q. So that's why the earliest time that we can start V, W, and U would be 14 hours. Okay, so now let's look at this node. So we need to complete U, R, and S. Only we can start X. So by the time that we finish U, it will be 70. By the time that we finish R, it will be 14. By the time that we finish S, it will be 18. So which means that the earliest time that we are able to start X would be based on S, right, which is 18 hours. Okay, so now continue. So in order for us to start Y, we need W, X, and T to be completed. So that's why 14 plus 9, we got 23. 18 plus 2, 6 plus 9. So the earliest time that we are able to start Y will be 23. Okay, because while these two finish first, we still need to wait for W. So that's why 23. So I need to make sure that both V and Y is completed. Only the entire project is considered as completed. So that's why 14 plus 18, we have 32. 23 plus 6, we have 29. So that's why at the 22 hours, then it's considered the entire thing is complete. Okay, so now we try LST. So we have, okay, I'll try to put in another color so you're able to differentiate what are the numbers that I do it for EST, what are the numbers that I put for LST. Okay, so for the last node, remember your LST is always the same as EST, so no need to check, straight away write 32. So looking at this node, there's only one edge that going backward for this checkpoint. So that's why 32 minus 6, we got 26. So which means that in order for us to finish the project in 32 hours, the latest time that we can start, the latest time that we should start Y will be 26 so that we are able to finish it on time. Okay, so now when we are looking at, okay, you can see that for this node, you need to look at all these 3 edge. So since you need this edge, then which means that we need to complete first this one first before you can look at that. Okay, so we can solve this one first because this node only depends on this edge that is going back, right? So 26 minus 4, that's we get 22. Okay, so now you realize that it still makes sense, like 22 plus 4, then you get 26, 26 plus 6, and you still get 32, right? Okay, so once we get this, then now the next one, we can check on this. So for backward scanning, then which means you need to check this edge, you need to check this edge, and you need to check this edge. Because all these 3 going backward, you go back to this checkpoint now. So 32 minus 18, you get 14. 26 minus 9, we get 17. Okay, then 22 minus 3, we get 19. So among all these numbers, remember to pick the smallest number because you are going backward. So because if let's say you start later, then you wouldn't be able to plus 18 and still get 32. So that's why this is 14. Okay, so similarly, when we are looking at this node, then you need to check 1, 2, 3, 4. So there are 4 edges that going back to this vertex. So 26 minus 9, we have 17. 22 minus 12, we have 10. 22 minus 8, 14. And then 14 minus 8, we have 6. So the smallest number is 6. Okay, because if you write any bigger number, when you plus 8, you wouldn't be able to achieve the 14 here. So 6 minus 6, you get 10. So that's why you know that your answer is correct. Okay, so I'm explaining in a way which is a bit more using the scale. So which means you just remember you minus for check which edge going back to that checkpoint. So minus, then you choose the smallest number. Okay, but you try to understand the, the situation that we have just now. Okay, so this is for example 2. And now we'll be going back to page 134. We'll talk about the last, the last learning outcome here. Then after that, we'll end the lesson. Okay, so the last part, we talk about float time and slack time, which is basically what we talk about, the deodorized, if you remember it. Okay, when we first learned about the minimum completion time. Okay, so we say that deodorize and clean inside, you can delay for 3 minutes, right? Okay, so now we are going to understand it better, and also we come up with a formula for that as well. Okay, so the amount of time that a task in a project network that can be delayed without causing any delay to the subsequent task or without causing any delay to the minimum completion time, that's what we call as the float time or the slack time. Okay, let me change another color. Okay, that's what we call as the float time or the slack time. Okay, so for example, from what we have understood just now, we know that the activity for deodorize has a slack of 3 minutes. Am I right? Because we talk about that this activity, we can delay it for 3 minutes before commencing. So instead of, we go back to this picture. Okay, so you can see that between your earliest starting time and also your latest starting time, right, then you can see that there's actually 3 minutes in between. So you know that if let's say you start as late as 29, you are still able to achieve the 30 here, right? Okay, so that's why that is 3 minutes extra. And these 3 minutes, if you delay, then your minimum completion time will remain the same. Okay, so this 3 minutes is called as deodorize. In other words, this 3 minutes is called as the slack time. Okay, sorry for that. Okay, so in another word, it means that this activity can actually start at any time between the 26 and the 29 minutes. Okay, because this is what you see, ma. The earliest that you can start deodorize is 26. Then the latest time that you should start is 29, which means if let's say I start at 27, it's okay as well. If let's say I start at 28, it's okay as well. The latest that you want to go will be 29 because 29 plus 1, you get 30, or else it will be out of the range already, which will cause your minimum completion time to be extended. Okay, so that's what we meant by you can do it in between 26 to 29. Okay, so now this is float time and slack time is something that is useful when we are talking about if you are looking at the node itself, then sometimes then for example, for the waxing and also cleaning inside, right? Just by looking at the note itself, it looks like their EST and IST is the same as if you can't delay them. But then but you understand that the 16 here is actually because of waxing, not because of cleaning inside. Because when we are talking about IST for cleaning inside, it's still 19. So how can we prove that it's actually from the flirt time? Okay, so try to imagine the situation that we are having here. Imagine for waxing. So try to understand the statement that I try to make here because it will be helpful for you to understand the formula later. Okay, imagine now for waxing, right? Because of the latest time that you should start polishing is 24, which means the latest time that you should end waxing is 24. Am I right? Because only if you ended waxing, then only you can start polishing. So that's why the latest time that you can end waxing is 24. Then the earliest time that you can start this activity is 16. So that's why in between your earliest starting time and latest ending time, you have 8 minutes. And you need exactly 8 minutes to complete this activity. So that's why you can't afford any delay. So your flirt time is 0. Okay, maybe I try to explain it by using slightly simple scenario. Okay, let's say today you have your normally you have your lunch hour 12 to 1 in the school. Okay, you know that today you actually need 30 minutes to complete your homework. Okay, we are talking about maybe you need 30 minutes to complete your homework. Okay, so because your break is like this one, so you know that the earliest time that you can start doing your homework is at 12. Am I right? So the earliest that you can start doing your homework is 12 p.m. But you must make sure that you complete your homework by 1. Am I right? So, and then you only need 30 minutes to complete your homework. Then isn't it means that you got extra 30 minutes? So this 30 minutes is basically your flirt. So how do you find out the flirt and slack is that what is the latest time that you should end it? Then you minus the earliest time that you can start, which means you have 1 hour. So 1 hour, you only need 30 minutes, then you know that you have extra 30 minutes for you to delay. So that's the same idea here as well. Okay, so which means that 24 is the latest time that I need to end. So the earliest time that I can start is 16. So that's why I have 8 minutes. So I need 8 minutes to complete this as well. So that's why I don't have any flirt time. So when you think about it, the idea is 24 minus 16 and you minus 8. That's how you get 0. Am I right? So when you think about the logic of it, so 1 p.m. minus 12 p.m., you got 1 hour, then minus 30 minutes, you know that you got extra 30 minutes more. Okay, so the flirt time for wax is basically 0, which we just now talk about the formula itself. We can also find it by using the formula, which will be B minus A minus T. The latest time that we end minus the earliest time that we can start, minus how many time that we actually need, and the extra one is our flirt time. Okay, so like 1 p.m. minus 12 p.m., then we got 1 hour minus 30 minutes. That's how we get the 30 minutes. So for waxing just now, that's how we see for the waxing. So you are looking at the bottom number. So 24 minus 16 minus 8. So that's how you get 0 as well. So you can either use formula or you can just use, like what I explained just now. Okay, because the latest time that you need to end is 24, but the earliest time that you can start is 16. You need 8 minutes, so that's why the number will be 0, so you can't afford any delay. Okay, but now let's look at cleaning inside out. Okay, so when you try to look at this, then you can see that because of deodorize only need 1 minute more. If let's say we assume that deodorize doesn't delay, then which means that as long as I end cleaning inside in 29, I will still be able to finish the entire project at 30. Am I right? So 29 is the latest starting time for deodorize. It's also the latest ending time for cleaning inside. So which means that it's okay if I end clean inside at the 29 minutes. And actually, I can start as early as 16. So that's why I know that in between, I actually got 30 minutes, right? 29 minus 16, I got 13 minutes. But I actually only need 10 minutes to finish cleaning inside. So how much extra time I have? 3 minutes, right? So from 16 to 29, I have 30 minutes and I only need 10 minutes to clean inside. So I can have the 3 minutes of flexible time. So this 3 minutes flexible time is basically the float time. Okay, or if we are talking about formula, then which means we will take the number down here, 29 minus 16 and then minus 10. So it's like you can see the value here. Okay, so that's EST, LST, EST, LST. So you are taking the ending latest, then minus the starting earliest, then you minus the activity time. So B minus A minus T. Okay, so that's why we have 29 minus 16 minus 10, and that gives us 3 minutes. Okay, I repeat one more time. This formula is not like a compulsory thing. If let's say you are able to understand from what we mentioned just now, like you can end as late as 29 and then you can start as early as 16. So in between you got 30 minutes, in between you got 13 minutes and you only need 10 minutes. So that's why I got extra 3 minutes. So you can just write down 3 minutes without writing the working as well. That's totally fine. So it's up to you whether or not you want to remember the formula or you want to just understand it. Okay. So another thing to remember is that because the EST and LST for all critical activities will be 0, which means that when you try to observe, okay, for example, from wash to dry to wax to polish, because all the number is the same. So you can imagine that when you are taking the number minus, right, you will always get 0. And it also reconfirm what we learned just now, which we say that your critical activity are the activities that you can't afford any delay. If you can't afford any delay, then which means that the float time will be 0. Okay, so remember, the idea is that if let's say it's critical time, the float time is 0, but having float time 0 doesn't mean that they are on critical path. Okay, so you need to remember the idea of that a bit. Okay, so that is the part for the float time. Okay, so what do you need to do next is that make sure that you have completed your question 3. Okay, so maybe I think take like maximum 10 minutes, you should be able to finish this. So try to answer all these questions. Then after that, tomorrow in the class, we will try to discuss question 3 together. Okay, so and you can just jot down any question that you have lah. Okay, so tomorrow in the class itself, hopefully we'll be able to see face to face. Then from that, once you can ask all the question and all the doubts that you have. So do make sure that you are able to do all the question for today, because tomorrow's lesson is going to build on whatever that we learned today as well. Okay, so make sure that you try out the example. Okay, so I will see you positively tomorrow. Okay, thanks everyone.